Dan, can you hear me?
Yes, I can hear you.
Okay, great.
We can, if Mr. Philip is in, you can start. The rest will join us as we proceed.
You said the Philip is in. Okay, great. I see Philip there. Good afternoon, Mr. Philip Kungu. How are you? I see you there. That's great. So everybody's here. So the interpreter is here. The recording is paused. As soon as you start the recording, I will start as well. Thank you. Hello, everyone, and welcome to today's ARSO and ASTM webinar on nanotechnology. Thank you for taking time to be here. I know for some of us, it's very early in the United States. For those in Africa, good afternoon, and still the same. Thank you for taking time from your busy schedules. I am Maria Giveraj. I'm a manager for global cooperation and training at ASTM International, and I'm delighted to be your host today. We have two great speakers today, and the first speaker will attempt to answer the question, how can ASTM nanotechnology standards drive innovation in Africa? While the second speaker will share with us some of the use of this technology in Africa, and also attempt to answer the main question of this webinar. The selection of this topic for this webinar, nanotechnology, stems from ARSO members' response to a survey that we sent sometime last year, spring last year, in which 4 other topics were selected. We had advanced 10 topics to ARSO and its members, and 5 of them were chosen as a priority. And those 5 topics include additive manufacturing, textiles, robotics, automation and autonomous systems, as well as petroleum. All those webinars on those topics were carried out last year. The last one was in December. And this topic was supposed to be covered last year as well, but due to time constraints, we were unable to do that. So this is the 5th and last ASTM ARSO webinar series scheduled for 2022. So we postponed to this year. Before I introduce you to the 2 panelists, I would like to, on behalf of ASTM International, express our sincere gratitude to the African Organization for Standardization, ARSO, for teaming up with us today as it has done in the past, in previous webinars and other collaboration areas. Our partnership with ARSO is very, very strong, and it dates back to 2015 when both institutions signed the Memorandum of Understanding. And this has been indeed a very, very fruitful relationship, partnership, and we have made tremendous progress to date. Before I invite Mr. Philip Okungu, ARSO's Documentation and Information Manager, to deliver his opening remarks, I would like to go over a couple of housekeeping items. And after Mr. Okungu gives his opening remarks, I will then introduce the panelists. So Mr. Okungu, as you know him well, will do the opening remarks, and the housekeeping items that I mentioned are that today we'll have 2 great speakers, like I said. Each will have 25 minutes to present. Attendees will be on a listening mode only, and during the entire webinar, with exception during the question and answer session, at which point they may ask to be unmuted. if they wish to do so. However, you can send your questions through the chat box. I also would like to advise and kind of ask, not so much of an advice, to ask if attendees refrain from using their cameras. This is to avoid any bandwidth problems. There is actually an interpretation feature, and that is available at the bottom of your screen. You can select the interpretation button there, and you can choose the language of your preference. Obviously, we have English and French for non-English speakers present today. And at the end of each presentation, we'll have 10 minutes for each presenter to answer the questions that you may have. Without any further delay, I would like to invite Mr. Okungu, ARSO's Documentation and Information Manager, who is in charge of the official information documentation, communication, and member stakeholder network and outreach, who also works directly with the Secretary General, Dr. Imogen Sengemana's office, to deliver his opening remarks. I will not go over Mr. Okungu, and I apologize for that, extensive bio, just for the sake of time. But you all know that Mr. Okungu has a lot of experience working, for ARSO. I believe Mr. Kungu has been with ARSO for quite some time, and he holds a master's degree in library and information science and a bachelor's degree in education from both Kenyatta University in Nairobi. And he also have various professional qualifications in standardization and quality infrastructure. With that, I would like to turn things over to Mr. Okungu. Thank you very much.
Thank you very much, Maria. It's my pleasure once more to be here. I want to take this opportunity to recognize our speakers, Mr. Brian Nelson. Please feel welcome, and we really acknowledge and appreciate your presence and acceptance to be one of the facilitators in terms of resource persons to deliver this lecture to our audience and delegates. I want also to recognize the presence of our second speaker, Professor Chomora Mikeka, who will in this case also present the case from Africa. We want to thank Professor Chomora for accepting to be a resource person in this webinar, which marks in the webinar series that we organized with the ASTM International for 2022. It marks the last of it, as we are also going to continue facilitating more webinars of interest to our members and experts, as they will once more will come back to them and identify more topics that they want to get more expertise knowledge on. Mostly on behalf of the Secretary General of African Organization, I want to thank the STM, and specifically I want to thank Maria Giverench for this facilitation, support, and consistency in ensuring that we deliver the mandate of our cooperation through a signed MOU. It has been a while for ARSO and STM, working together, and I think we continue to expand our areas of cooperation, including training and capacity building, standard harmonization and referencing, and just mutual relationships that we enjoy together. We want to thank STM and management and administration for facilitating that. And mostly we want to thank Maria. And mostly also I want to take this opportunity to welcome all the experts, the stakeholders who are already logged in and following in these discussions. It's going to be a great opportunity for us, because the topic that we have today was an expressed interest from our experts and member states. And as Maria had indicated, it is the final in the series that we identified. But I want to assure you that this is not the end of our webinar series. We are going to see what we are going to do in 2023 in terms of this capacity building and training through the webinars that we have been having with ASTM. Another development on the same, I think, from our Secretary General, as also we have agreed that for all those who are participating in this webinar series, because they are more of training, because the expertise that we get, the expertise, knowledge, and experience that we have been receiving from our speakers are worth documenting through certificates or certification. So in this case, henceforth, we are going to follow up from where we started with STM and provide certificates for all the participants who have been participating in our webinars. That is how serious we have taken this, and that is how we want to appreciate all the experts that have been participating in our webinars. With that, I want to thank you once more on behalf of the Secretary General for this opportunity to have this expertise webinar today, and thank Maria also for the facilitation and the role she's steadily and consistently been doing. It is our pleasure, and we thank you so much. Thank you for now, and I welcome you all to this webinar. Thank you.
Thank you very much, Mr. Kungu, for such words of kindness towards the ASTM. We value our partnership with ARSO, like I stated at the beginning of this event. I now would like to invite the first speaker, Dr. Brian Nelson, who is a research chemist at the National Institute of Standards and Technology, NIST, and he's also the chair of ASTM E5608 on nanotechnology, enabled medical products, and he has been in that capacity, serving at that capacity since 2017. Dr. Bryant, is also a member of the American Chemical Society since 1998, and he advises the Biomedical Science Careers Program at the Harvard Medical School since 1996. Dr. Bryant has authored various articles, including Emerging Standards for Nanotechnology Enabled Medical Products, which was published in 2020. I will attempt to share a link during this webinar where you can gather more information about Dr. Bryant. With that, I'll turn things over to Dr. Bryant, and then I'll introduce the second speaker after Dr. Bryant has concluded. Thank you very much.
Thank you, Maria. Thank you for the kind introduction. Can you hear me okay?
Yes, we can hear you okay. Thank you.
And the slides are good?
Yes.
Okay, perfect. Yes, I'm very delighted to have been invited to give this lecture to you all this morning in terms of the ARSO ASTM collaboration, specifically on nanotechnology. And I will attempt to answer the question about how can ASTM nanotechnology standards drive innovation in Africa. I'm wearing two hats this morning. I am very heavily involved with ASTM E56, which is nanotechnology, but I'm also a researcher at the National Institute of Standards and Technology. So I come at standards from two different directions, but they all lead to the same conclusion, that standards deliver quality. My lecture today, I would like to go over the definition of what is a standard, how do you get to a standard. Then I'd like to give a brief overview of the ASTM structure, specifically the structure of ASTM E56 nanotechnology. And then I'd like to end with a specific example from ASTM E5608, which is deals with nanomedicine, nano-enabled medical products. Okay. All right, so what is a standard? So a standard, in the terms that we're going to be discussing this morning, is a document that lays out the exact specifications for producing a product or a guideline. The definition that you see on the screen right now is from ARSO. It's a very detailed definition that describes a document that is established by consensus and approved by a recognized body that provides for common and repeated use, rules, guidelines, or characteristics for activities or their results, aimed at the achievement of the optimum degree of order in a given context. And standards are based on the consolidated results of science, technology, and experience, and aimed at the promotion of optimum community benefits. So ISO and also the NIST definition and also the current ASTM definition are all aligned in that a standard is a document that is produced through a consensus type of agreement, so that all parties involved in the development of the standard come to an agreement as to how the final standard should look like and what it should say. So in ASTM in particular, standards come under different flavors. There's different types of standards that we produce. We have specifications, test methods, practices, guides, classifications, and terminology standards. I will not be going over any of these in detail right now, but if you have questions about these different types of standards, we can talk about them at the end. We'll hear a little feedback right now. Okay, so why are standards important? Well, standards are actually extremely important for a variety of reasons. Standards generate impact, and they give us access to markets that we might not normally have access to in terms of business. They document what we're doing right and what we're doing wrong in terms of producing products or services. They improve, of course, they improve the quality of all products that we are trying to work on. They accelerate innovation. And most importantly, they drive business objectives. And they also meet our regulatory objectives across the world. Now, in terms of the types of standards that ASTM develops, we're only going to be talking about documentary standards. So these are written documents that are produced that clearly describe the aforementioned specifications, test methods, and so on that I alluded to earlier. And they're produced through a consensus method where all the comments that are put on the document are addressed. And usually the development of these documentary standards are produced by subject matter experts. And they provide a common ground for manufacturing and product development. And finally, the use of pre-competitive standards enables the production the speeds quality products onto the market at a much higher rate. And I've already talked about what pre-competitive documentary standards are. And so how do we get to development of standards? Well, in general, now this example is regarding nano-enabled medical products, but it could be applied to any type of product that needs to be produced. At the very bottom of the pyramid, you see there are a lot it's very broad, consisting of production of data and measurements. So you have to develop an assay to produce this data and measurements. There's all types of academic and industrial and government based measurements and data that have to be consolidated. So how do you consolidate these different types of assays? Well, you have to use a type of measurement metrology that ensures that the data has consistent measurement assurance. And the way you do that is you use a variety of tools, such as cause and effect diagrams, design of experiments, process controls, and reference materials to inform that the measurements that you're making are actually valid measurements. After you've done all of this, you go further up the pyramid and you will finally achieve a documentary standard where there's a test method, a practice, or a guide. And you can use these documentary standards to, in this case, ensure the product quality of, for example, of a mRNA LNP vaccine or a drug product. So overall, if you go through this process, which is very time consuming and can be expensive, you will produce in the end a product that has built-in quality and safety and efficacy. So for nano-enabled medical products or nanomedicines, there are a variety of different targets, measurements that need to be taken into account. It's a very busy slide, but I only want to emphasize that the measurements that that are unique to nanomedicines are being able to measure surface properties, biological properties, chemical properties, and physical properties. And if you can do all this, you can ensure the safety and efficacy of the final product. So you have to be able to measure the critical quality attributes of all of these different types of nanomedicines that are either on the market or coming onto the market. And so the overall point is that you have to have a basis for a good measurement science in order to make these measurements of, for example, nanomedicines valid. So the components of measurement quality are 4 things. You have to have traceability of the measurement, which means that the results are traceable to a appropriate reference, a reference material. The measurement system has to be fit for purpose or validated. You have to take into account all sources of bias and uncertainty. And finally, you have to have a quality system in place that will ensure that all the measurements that you make are reproducible and traceable. Now, I just want to briefly give you an example of some selected US standards organizations. Of course, NIST is one where I come from, and then ANSI, and then the USP and IEEE are some examples, other examples. And then other examples of international standard organizations are, of course, ASTM, ISO, the European Pharmacopoeia, VAMAS, the BIPM. So many international standards organizations are out there, and they all work toward the same goal, to try to produce high quality, reproducible standards for the marketplace. Now, in terms of ASTM, ASTM has produced more than 12,000 standards globally, just about all areas of life. Some of those standards are produced by different ASTM committees. We have committees for example, that are devoted to steel, stainless steel, and related alloys. This is ASTM A01. We have a committee devoted strictly to paint, ensuring the quality of paint, Committee D20 is devoted to plastics. A really very large committee, FO4, is very broad and it covers many areas of medical and surgical materials and devices. So I wanted to just give you a flavor of the different types of committees that ASTM has developed and that are ongoing. So who are ASTM members? Typical member like myself. They are scientists, engineers, business leaders, anyone who has a deep expertise in a particular area or interest in a particular area can join ASTM. There are more than 145 technical committees, some of the previous ones that I just alluded to. And we represent more than 135 different countries. So it's a very large organization, international organization. And I'm going to go ahead and urge you to join the ASTM if you're interested, because we have a very large impact on business around the world. And so how are ASTM committees organized? Using E56 as an example, there's usually the main committee that is focused on a particular industry, in this case, nanotechnology. And then there are subcommittees underneath the main committee, .01, .02, and .03. And then there's task groups underneath the subcommittees that work on particular problems for each of the subcommittees. And any of the ideas that are brought to ASTM will be taken into consideration for development of standards in these committees. So once a standard is drafted, and it has to go through a balloting and review process, and all of the comments that are made on the standard are addressed and taken into considerations, especially objections. The objections or no votes have to be completely addressed and agreed upon for the standard to continue through the ASTM approval process. And all standards are reapproved every 5 years. So we also support standards development via our own internal interlaboratory studies program. This is a program where the standards are assessed for precision and bias throughout a vast program of different laboratories testing the standards reproducibility. And the ILS program provides not only administrative support to the testing process, but also offers financial support and also helps identify labs around the world who may be interested in participating in the study. Now I would like to focus on my remaining time on specifically E56, Committee E56 within ASTM, and give you a little bit of information about E56. So what is the scope of E56? Well, it is a specifically devoted to development of standards and also guidance on the area of nanotechnology and nanomaterials. It coordinates all of the ASTM standards work related to nanotechnology. And we do this both internally and externally through the development of symposia and workshops and other types of meetings that are ongoing throughout the year. And now the structure of ASTM is such that it was first of ASTM E56 is that it was first developed in 2005. So it's a little over 20 years old. And they're currently consist of 165 members from more than 20 countries. We meet twice a year on different locations with about 20 members in attendance, and the other members attend virtually. We have a total of 7 technical subcommittees, and right now we have 32 active standards and 14 in development. And some of the committees, the committee structure actually is the technical committee structure shown here on this slide, where we have the 7 committees, informatics and terminology, physical and chemical characterization, environmental health and safety, liaisons, and international cooperation, nano-enabled consumer products, education workforce development, and my committee, nano-enabled medical products. And then we also have an executive committee, E56.90, which handles all of our high-level organizational interests. Right now, Debbie Kaiser is our chair, and I'd like to recognize our staff manager, Frank McConnell. Now, the homepage for our committee is shown here. You can see at the bottom the address. If you'd like to get more detailed information about E56, you can go here. Now, how do you actually participate in E56 and become a member? To talk a little bit about that process now. So if we have, if there's a standard that needs to be developed, usually members of the committee identify the need or bring in someone external to the committee who recognizes the need and will give a presentation about the importance of this standard in this area of nanotechnology. And so we bring together all of the stakeholders in a certain area of nanotechnology, and whether they're from industry or academia or government, and we have discussions about the actual need for such a standard in this particular area. There may or may not be a need, so we come to a consensus that addresses that. So the process is that if you think a standard in an area needs to be developed, you contact ASTM. We will register that standard as a work item if it's approved, or draft a standard through using our task groups and committees. We'll have a first subcommittee ballot, then we'll have a main or concurrent ballot if it passes subcommittee. Then it'll be approved and by the host society, and finally it'll be published as a standard from ASTM International. And I'd like to end by talking about some of the standards that are specific to E5608. Some standards that have recently been completed are standard test methods for lipid quantitation and liposomal formulations, using 3 different types of detectors. One method utilized a charged aerosol detector. Another method used a evaporated light scattering detector. And finally, the last method used a triple quadrupole mass spectrometer to measure the lipids. And then finally, we had a recent test method that was approved and published for the detection of nitric oxide production in vitro. Now, some of the work items that are ongoing inside of E56 include the top one, a standard guide for characterizing of the encapsulation, extraction, and analysis of RNA and lipid nanoparticle formulations for drug delivery. And then we have others like a standard test method for the analysis of liposomal drug formulations using multi-detector asymmetric field flow fractionation, and several others that are in development. But I'd like to focus on the first one, since it's highly relevant for what's going on in the world in terms of COVID right now. And this is a standard related to development of mRNA LNP vaccines. Right now, since last year in 2022, there have been 5 main SDOs, or standard development organizations, developing guidelines or guideline documents for mRNA LNP vaccines to ensure the quality of these types of vaccines. These SDOs include ARSO, USP, the WHO, our committee in ASTM, and also the European Pharmacopoeia. So this particular guide that we're working on within ASTM is focused on, the quality characteristics of the RNAs part of the LNPs. And we are trying to provide high-level recommendations to the industry for best practices in terms of analytical methods. For example, for characterizing the mRNA encapsulation efficiency, for looking or investigating the qualitative and quantitative extraction of LNP encapsulated mRNA, and also investigating and characterizing the identity, integrity, and purity of mRNA before and after encapsulation in LNP vectors. So our guide is strictly focused on those three areas. Other guides are documentary standards that are being worked on around the world, focused on other areas. And this is an outline of the guide that we're working on. It's currently 55 pages long. It has the scope of the methods, apparatus needed, sample preparation considerations, applicability and limitations for mRNA LNPs. And of course, you have to have an in-depth discussion on quality controls and acceptance criteria. And finally, this is how the guide is broken up into sections. Three main sections: extraction of RNA from LNPs, methods to assess RNA quality, different methods, and methods to assess RNA encapsulation within LNPs. So it should be, in the end, a very important guide for the industry as new mRNA LNP vaccines are being produced for different strains. And we hope to have this out by the middle of this year. And with that, I'd like to take any comments or questions. You can contact me at the email address listed on the slide. And I hope you enjoyed this presentation. It was a very high-level presentation on ASTM, ASTM E56, and some information about ASTM E5608. Thank you.
Thank you very much, Dr. Bryant, for such an insightful presentation. I'm glad that you walk us through the ASTM Technical Committee E56, in which you are part of. You gave us the scope, the work that you have been doing, and I hope that our participants found it very, very useful as we attempt to answer the question, how nanotechnology drive innovation in Africa. I will ask you to kindly stay on to answer questions, and those questions may come via the chat, because I would like to quickly proceed to the next presenter, who is Professor Chomoro Mikeka.
My pleasure.
Thank you very much. I encourage you to stay once again, as we'll also have the question and answer session. Thank you very much, Dr. Bryant. I appreciate that.
Sure.
So now it's my great pleasure to introduce you to Professor Chomoro Mikeka, who is the Director of Science, Technology, and Innovation, DSTI, in the Ministry of Education of Malawi, a neighboring country to my home country of Mozambique. And Professor Mikeka is also an associate professor of physics, where he focuses on wireless communications at Chancellor College at University of Malawi. He holds a doctorate in engineering from the Division of Physics, Electrical, and Computer Engineering at Yokohama National University in Japan, and is the chairperson of the African Standards Organization, ARSO TC 78 Medical Devices. He's also part of the National Commission for Science and Technology, Pharmacy, Medicines, and Regulatory Authority, and also the Southern Africa Development Community. I won't go any further with the details, simply to avoid going over the time that we have available for us today. So Professor Mikeka, if you now ready, you can take over the mic. Thank you very much.
Obrigada, Mariah.
The
What
Nano.
I would just a moment. I would I would like, I was using two devices, so just to make sure that I'm able to be audible. Am I audible there?
Yes, we can
Yes,
hear you,
yes,
sometimes with a little
yes.
echo, but for the most part, we can hear you well. Thank you.
All right. No, allow me to switch on the other device. I'm making an attempt.
Yes, please take your time, Professor. You're muted, Professor Mikeke.
Yes,
Okay, great.
no, I would like to remove the screen for now and do
That's
one
fine.
sharing.
That's fine.
How is it there?
Yes, we can hear you well.
Am I audible? Can I just get a confirmation now?
Yes, we can hear you loud and clear. Thank you very much. You may proceed.
Mariah,
Thank you.
Yes.
can I get a confirmation of Philip if
Yes,
I'm audible?
Yes, Professor, you are audible enough. It's okay. It's very okay.
Philip,
Yes, I confirm you are it's very all right. It's very good. It's okay. Do you want us to share for you the screen?
no, yes, no, I think now I'm fine. So I will start. Just assure me how many more minutes? Is it 10, 15 for presentation?
I had given 25 for each of you. So
Okay.
I think, if you could
I'll
do,
do 20.
yes, 20, then 20 will be good. Thank you very much.
Obrigada, Mariah, but also feel the moderators and all our distinguished participants who are participating virtually. Nanotechnology, and therefore why nanotechnology is the title of my presentation. And often a time when I'm making presentations of this sort, I often am reminded of the words of Hero, the elder of the Jewish tradition, who asked the question, if I am not for myself, then who will be for me? And being for my own self, what am I? And if not now, then when? If nanotechnology is not considered today, then when shall it be considered? And if Africa does not consider nanotechnology, then who will consider nanotechnology on behalf of Africa? Now, those are the questions I, Hillel, and also Ronald Reagan, John F. Kennedy used to ask since then. In the presentation that we have, I'll be giving a very simplistic definition of nanotechnology, but also I will share the bootcamp that took place in Africa, in Egypt, Cairo, New Cairo, on the nanotechnology recently, a few days ago, January to February. And therefore, why should this matter? What are the possible applications to solve the societal challenges in Africa using the nanotechnology? And then I'll make conclusions, but when I'm making the conclusions, I will invite you and I to recall the words of Kwame Nkrumah in 1963. And then we will be able to see the way forward. The simplest definition of nanotechnology is considered to be the manipulation of matter on a near atomic or close to subatomic scale to produce new structures. So that's the goal. New structures, new materials, and new devices. The technology promises scientific advancement in many sectors. Now I will start, for example, the sector of health, but also nutrition, aspects of nanomedicine, which my predecessor presenter did well speak about that. There are promises, scientific advancement promises in the area or sector of trade, the consumer products, but also in the industry, materials and manufacturing, but also energy. So on the energy, this is something which I, for one, when I was working on my PhD in Yokohama, Japan, I think over a decade ago, 2009 to 2012, part of my work was to harvest energy from the radio frequencies or the signals that often a time we are bombarded with in all the radio bands, FM, medium wave, TV, digital TV, satellite, mobile communications, both civilian and military, communications, radio communications and wireless communications. So I was keenly interested to find emerging, technologies and techniques to be able to harvest or scavenge those levels of energy for use to power sensors. And some of the energy levels were very small, micro, levels and nano levels. So I was dealing with nano energy levels in terms of nanowatts. And sometimes I was prompted to dive into, and then it was considered to be an emerging technology of using nanotechnologies, particularly the single word carbon nanotubes, but also the multi-word carbon nanotubes. So we call them SWCNTs, but also MWCNTs. We in Japan, in our own laboratories, were able to fabricate these single word and multi-word carbon nanotubes as sheets. And then we were able to use them appropriately. For me, I was able to use them to induce or bring some activation or sensing capability in antennas, which are used to call smart antennas. Antennas being used for sensing, radio frequency identification, but also energy harvesting. And it was actually the work of nanotubes, single word carbon nanotubes, which when I give a drop after fabrication, curing, culturing them, they were able to be useful for that. And that's a device. So in terms of products or industry, that came into that regime, but the purpose being for energy, for energy generation, including micro energy or nano energy generation to power sensors. Recently in this country, I think from December, in Malawi, in Africa, UNESCO, which is a UN body, did make invitations to member states to send representations of their experts, particularly those who have studied physics or engineering or sciences in general, who would qualify to have an understanding of nanotechnology, nanochemistry, and related aspects, nanophysics, to generate, to proceed with support of UNESCO to Egypt and New Cairo, where there was a boot camp on nanotechnology entrepreneurship. A program that was scheduled for end of January to early February. In our own country, we did, through my own directorate, as Director of Science, Technology and Innovation, extensive evaluation of possible potential candidates. And the Ministry of Education and Government finally approved a team of 5 who now have formulated themselves into what they call as the Nanotech Malawi. And one of them was financed. It's actually a lady who has a PhD in physics from Tokyo University, Japan, and she's a member of staff at one of the Malawian public universities, Malawi University of Business and Applied Sciences, Dr. Estina Katengeza. She represented this country in Cairo in that boot camp, showing the relevance of a program on nanotechnology, which we still consider in Africa as an emerging technology. And whilst they were there in the boot camp, it was very clear, for both those who were participating from outside the African continent, but also the African continent member states and in the scientists and the engineers, that nanotechnology opportunities and challenges in Africa could clearly be seen and be appreciated. And a look at the Sustainable Development Goals did reveal that there are many opportunities for nanotechnology, particularly in Africa, which has the largest population and greatest needs in the sectors such as the health, energy, agriculture, and sanitation. So under sanitation, we can say water and sanitation. And in agriculture, it's very clear. And in agriculture, Israel has done one of the most, I think, groundbreaking, discoveries of converting vegetables into necessary protein, like fish protein or beef. And this, I think, we have seen using the innovative way of application of nanochemistry and approaches, getting closer to the atomic structures, reconfiguring those ones, and creating, a product which smells and tastes and has texture close to or what it is exactly of fish, and therefore you're able to have, meat and fish products from fruits and vegetables, and this has been demonstrated and only been possible using nanotechnology. And in the energy, I've already highlighted that, in several other areas. But also, it was very clear that current nanotechnology data shows that the top 5 trends are in. So XYZ, I've been a teacher and a professor of physics for a long time, and normally sometimes I leave gaps for the audience to be able to guess what those specifics could be. We are, most of our member states and in countries globally, being driven, making decisions which are data driven, and therefore we want to reflect what does the data say. So the data does show that carbon nanomaterials is one of the top 5 trends in the nanotechnology, carbon nanomaterials. Secondly is semiconductor nano devices. Okay? And then thirdly is green nanotechnology. And then fourthly is nanocomposites and then nanosensors. For those who are unfamiliar to this field, but they are participating in this webinar, I would like you to recall and remember this. First is the nanomaterials, just materials. Second is just devices. Third is the green technologies. We have heard of blue economy, and green technologies. And in fact, I am also working on the co-chair of the African Union, European Union Innovation Agenda, and the green economy or green innovation is one of the big pillars and themes which will be financing billions of euros from this year, once there's a ministerial approval, June onwards to the next years. And therefore, nanotechnology is well situated to be exploited and also to exploit the financing which will come from the EU innovation agenda, particularly on the green transition. It's actually called the green transition. And then the fourth one, simply remember composites, because nano is the key word in there. Lastly, think and look at sensors. Some of you could be in Internet of Things, and therefore you'd have IoT, which are using nanosensors. Some of you are in the medical industry or health sector, or what you need to remember are biosensors and biomarkers. These could be using and exploiting nanomaterials and nanotechnology. For some of you, when you listen and you read the text, you may not remember and recall what we're talking about. So I'm giving you figurative and diagrammatic exposition of exactly what, for example, nanomaterials or carbon nanomaterials are. So this is where you see a case of what I mentioned, which I used in Japan 14, 15 years ago. Single word carbon nanotube. You can see it in there to my right on the slide. And also the multi-word carbon nanotube on the other side, which is cyclic. I have fabricated from scratch the single wall carbon nanotubes when I was doing my PhD, not as part of my PhD, but as part of curiosity, because I had almost completed my PhD and I wanted to put in a 6th chapter, which was looking at the future, techniques of doing the same thing which I was proposing and defending for my PhD in 2011 and 2012. And therefore, the 6th chapter, as future work, exploited the possibility of nanomaterials and particularly the single-wall carbon nanotubes. And I had to walk through the whole process of generating the single-wall carbon nanotubes and using them for devices in engineering and electronics, particularly. The second aspect, as you can see, is that the nano devices. So you look at micro or nano chips, including the possibility of having injections. Most of you, when you go for medical attention, you do not like if the prescription is that you have an injection. Many resent that. I, for one, I like it. But in future, we should be talking of, maybe even the present moment or time, to have needles or injectors which are nano, and you didn't even feel a pinch of it. A mosquito bite would be much more painful. So this way, we're talking of what my colleague earlier on talked about: in situ, in vitro, in vivo, and in vitro, administration of drugs. So in this case, we are talking of needles which would be nano needles, for example. And then the applications of green nanotechnology, where I said already there would be earmarked financing for green transition, and green nanotechnology would find a place in there. Applications of green nanotechnology goes into water treatment, biotechnology, medicine, textiles, and clothing. I should also mention here that in Japan, I also worked on vests, which you just put in a single layer of clothing or textile, which is fabricated with materials which have capacity to absorb the heat energy from the near infrared light. So NIR, but also FIR, the far infrared light or radiation. So far infrared radiation and near infrared radiation, that band in the electromagnetic spectrum, you could generally create and fabricate a clothing so that you don't put on too much on your body, just a simple vest, which is nanomaterial based, and targeting a specific wavelength in the wavelength in the electromagnetic spectrum, and absorbing the heat that you need to keep yourself warm. That we have done. And therefore, in food preservation, the case of Israel, where you are able to get fish from vegetables and the energy and the other. So that's the green nanotechnology transition. And fourthly, which is also very interesting, is the conductive nanocomposites, where there are materials, structures, and applications. And applications, which are just highlighted on the applications, you see that even a battery, in the present and in the future, you may want to use a battery which you are using in your radio set or a TV, a radio, then you want to put the same battery in your cell phone, but because of space in the cell phone, it may not fit. You can, if that battery was made of nanomaterials, flatten it from any other cylindrical shape, the flat shape, like a paper-based battery. So this could only be possible if you are using, nanomaterials. In Africa, there is a huge potential market to make batteries or recycle certain batteries and produce batteries, because energy storage is of great interest. And then nanosensors. The nanosensors is that all the sensors we're talking about in the applications of the biomarkers, biosensors, but also IoT, Internet of Things, and integrated and related, sensors. And the projections, data projections, maybe using artificial intelligence, deep learning, and the related aspects, do show in the focus and the foresights using that big data that the global market for the nanosensors will rise up to $1,321 million US dollars. And in my currency, it's a billion, thousand billion. Reach of global market by 2026, as projected from 2019. So this is shows that there is potential for nanosensors. So any company, any individual, any scientist, any professor, any innovator and inventor who would just focus on the nanosensors, they're more likely to have a market share from that huge market. And therefore, standards to that effect would be very important, because what would actually, declare and decree the viability of such a nano sensor to be placed in the market are the standards. I should also remind the audience, or recall when I was doing my master's and PhD in Japan, we developed so many sensors also based on this, including the carbon nano sensor, just to sense the presence of carbon and maybe even concentration. But also we developed the same for sensing of the so-called ammonia gas, you see, which are normally obnoxious gases and sometimes even poisonous. So these are the kind of sensors that we're talking about. And in the process now, Africa is doing a lot of biogas generation. And when you do biogas generation, from that process, you produce a mix of so many, a spectrum of a lot of gases. And sometimes you need a gas spectroscopy to do the analysis. And the sensors who do those analyses can be built from nanotechnologies, and they could be nano sensors, and then give the results that we want. This is an area of research in case there are academics and researchers with us. And therefore, it is important to do certain things in the lab, but to move from the lab to the market, because we have seen the potential market. We have seen how much is already at stake for exploitation in the market. And therefore, we need to think about that. And also the African Organization for Standardization, represented here by Filippo Kungu and the others, Daniel, and the other standards body like ASTM, the American standards bodies, and all the others. We should be able to see the niche and the area for possible exploitation. African Standards Organization, ARSO, also in the TC78, in which I'm the chairperson, we are looking at the harmonization processes. Most often the time, we look if there's need and a demand for a specific standard, either for a product which is new or a product which is known, we may sometimes borrow from the existing standards. That's why we're working with all the other international standards bodies, Chinese, European, American, and the International Standards Organization. We look into that documentation, the documents, analyze them, and sometimes we borrow them for exploitation within, in terms of adoption or adaption or any other related kind of aspects that we do based on the modeling model which we call ASHAM, which gives us the harmonization of standards. So as a guideline for the African standards harmonization model. So we call it ASHA model. So there is need for standards, ensuring that there is also sustainable production. No product, whether it's a nano sensor, would sell in Europe, in US, in China, in Asia, or even in Africa, if the process of development does not show a level of sustainable production. It is not green enough, it's not eco. So all those kind of mix must also be seen to be part of that. Following a leaf from my first presenter, he did present on ASTM standards, and I spoke to some of them. This is just an example of how ARSO, where I work in part as the chairperson for the technical committee of 78 medical devices and equipment. We would look at standard guides, would look at, for example, standard test methods. So you see the last one is looking at the EHS effects, for example, on the analysis of hemolytic properties of nanoparticles. So you'd have a nanoparticles, nanosensors, but then you want to look at, are there any properties, hemolytic properties? And then we can borrow that standard ASTM E2524 and just read through technical committees, through our working groups. And if we think that that is, and there's no any other update since 2013 or version, no version or addition, then if we are satisfied, we would adopt it. If we need to make some changes to contextualize to the context of Africa, we do the same. That begins an adaptation. And then we have all those commentaries in the framework that we normally do. Similarly for ISO, which is a technical report for TR, and then that is giving us a guidance on the physical chemical characterization of engineered nanoscale materials, because most of these materials you could reverse engineer, or formulate them from scratch. So all those kind of things, they need to comply. And in the first one, ISO TS gives us the details, the general vocabulary and the core terms of nanotechnologies. For the newbies, for those who are interested in this field, they would consult, for example, ISO TS 8004, just to look at the vocabulary and the core terms. This is how we use the standards in our context. Therefore, what are the typical applications of nanomaterials? We don't want just to talk theoretical. We want to pitch down, come down and land in Africa and see, is nanotechnology useful in Africa at all? Would this attract the interest of the politicians or the policymaker, the citizens, and the scholar and the industry? So part of the boot camp, which met in over 12 teams met in Egypt, New Cairo, January, February. Some of the member states which were there were Malawi, Mauritius, and Mozambique. And fortunately, Malawi, Mauritius, and Mozambique were grouped together in the bootcamp. So teams were formulated. And I'm happy to inform to our moderator, Mariah, who is present here, that Mozambique paired with Malawi and Mauritius. And in that grouping, the problem or societal problem they were given to solve using nanotechnology was water purification. So I'm coming to applications, landing down to what really matters most. And the water purification, I don't know whether this was motivated and caused by Malawi or Mozambique, but the water purification came out to be the issue. And this is one of the critical crisis issues in Malawi, where a large proportion of the country still depends on surface and groundwater from wells and boreholes. So the groundwater, treatment is not. You simply dig a borehole, and most of the water is consumed directly, without even sometimes doing tests to see compliance and conformity to WHO standards in terms of water which is fit for consumption. And similarly, so those kind of assumptions have caused problems. For example, I would say here, the utilization of nanotechnology for water treatment may provide excellent solutions to some of the regular problems and crises that come with poorly or untreated water, such as cholera. Malawi is not an exempted sea. If you look at the newspaper, Malawi cholera death toll has passed 1,000 as outbreak. Healthy News, Al Jazeera, just the past 2-3 weeks, and our schools were closed, some of the major cities, because the water which was consumed by our learners in primary and secondary was from boreholes dug within the campuses or premises of the schools, and that meant that if the water is used, the borehole is drawing from the groundwater, including surface water, and somehow they have interfaced with peat latrines elsewhere, then obviously the water was exposed, and without treating it, cholera becomes the issue. And you would also see here that some of the standard operating procedures for working in the education sectors, or even the public places, is to have water, hand washing, provisions in the buckets of this. If this water is also unclean and treated, obviously all those who are using it, even though it's used for sanitation, it still exposes the user or the consumer to possibilities of cholera and salmonella and several other aspects. This is a case of cholera outbreaks played throughout the southern region of Malawi, and Partners in Health is treating there a cholera patient, and that has been the situation in Malawi. And therefore, nanotechnology for water treatment was seen to be more strategic, and we have our scientists come back, the physicists, and they are working on the possibility. They demonstrated how to treat water using nanotechnology in Egypt, and they have now to popularize this in the universities, in the industry, and therefore for the good of the whole nation, both in Mozambique, in Mauritius, and in Malawi. Conclusion. There is need, therefore, for nanotechnology, standards, and business. Those who are doing it must see a business sense, including the universities. So therefore, the nanotechnology entrepreneurship is important. And in that way, we should be able to solve the 1963 problem. And what is this 1963 problem? Africa, the problem is that we have abundant raw materials, as I'm concluding now, too much that we're not able to consume. Resources are there, And it's all for us to marshal them into the active service of our people. We have resources in Africa. I'll not read what is written in text in there, but obviously you should be able to relate when we are saying that Africa has a huge potential to do anything else because we're endowed with a lot of resources, including the hydroelectric power and stuff. It is obviously these were speeches and statements which were made at the first organization of the African Union or Unity in 1963 in May in that year. And John F. Kennedy did mention and say that to those whom much is given, much is expected. Africa has been given much from population to the resources, and therefore much is expected in terms of what we produce as Africa. If we're talking of all those nano products, including the nano sensors, most or a greater proportion of them should come from Africa. And that should induce the need for standards, again, from Africa. Therefore, ARSO is here challenged. Researchers and scientists, engineers are here challenged, and all the other partners from the other continents. You are also challenged. The philosophy to solve the African problem since 1963 is contained in these words. A decade ago, these would have been visionary words, the fantasies of an idle dreamer. But this is the age in which science has transcended the limits of the material world, and technology has invaded the silences of nature. This includes nanotechnology. Time and space, as was observed by Schrödinger, have been reduced to unimportant abstractions, and giant machines making roads, clear forests, dig dams, lay airdromes, and monster trucks, and all that. Huge laboratories manufacture drugs. We would like to see medical, nanomedicine plants in our African countries, all the 54 or 55. Red Malawi is in the process right now with support from Iceland to be able to put up a drug for medicine for the under 5. Could this be an opportunity also to include the possibility of nanomedicine for the under 5s, which should be easier to administer to those 0 to 5-year-olds? Complicated geological surveys and several other aspects as have been seen in here. The world is no longer moving through bush paths or on camels and donkeys. We are on a revolution, and this is no other than the speech of Kwame Nkrumah. And with those few remarks, I wanted to show you one thing. In Malawi, we are endowed, we have the opportunity to produce nano material, nano sensor, nano everything, nano devices, because we have deposits of graphite. There is Chimutu there is Malingunde, there's Kanyika. If you just check this, and this is a public information, is available, I think, online, you will find that one from the slides which I presented earlier on, one of the sources of creating those carbon nanomaterials is graphene. And you know that one of the Nobel Prize winners in 2006, if not 2009, was working on nothing but graphene, making semiconductor devices, transistors, and everything else, integrated circuits from graphene or graphite, and the British, physicist. And therefore, we have an opportunity. I'm sure that Malawi is just one of those, because we have not begun exploiting this graphite or graphene for the purposes I'm talking about. And I'm sure that there's several other African countries who are doing that. We would like to call upon those who have studied mining, mineral, explorations and related aspects to be able to point to this, break that, ore, the graphite ore which we see, analyze it, and separate the carbon, molecules or atoms at that level, and be able to begin to process and manufacture what I did in Japan 15 years ago, single word carbon nanotubes, including the mud word carbon nanotubes. It's from, carbon, which we see in there. I just tried to take a strip of that and they connected some voltage, positive and negative, from a DC, bench, power supply, dual rail power supply, which you see on there with my student, a third-year student, when I came back from Japan. I think that was in 2012 or 13 thereabout, and we were able to produce light from that graphite ore, or even from a pencil lead. This is what we're talking about. And if this can be done at nanoscale level, this is exactly what we're looking at. With those few remarks, I would like to submit, moderator Mariah, my presentation, just to induce discussion and deliberation in this webinar on nanotechnology, and therefore, why nanotechnology? Thank you. I submit.
Thank you very much, Professor Mikeke. Your presentation was indeed very insightful. You touched upon a lot of points. It seems to me that we will need to invite you for another presentation at some point and work closely with us at ASTM. You had a lot to share. I like the fact that what you had to share with us about the Cairo boot camp. I would like to learn more about that myself, and I'm sure others would like to. So if you have any um, link or any document that you'd like to share with us regarding the outcomes of that boot camp, and also what you concluded with the graphite deposits that you have in Malawi, which may mean that Malawi will spearhead the use of this nanotechnology in Africa. That will be wonderful. I would like now, because we don't have much time, I would like to move on to our question and answer session. And before I do that, I just want to confirm with you, Professor Shimura, that you did not have slides, right?
No, so what I did is I have formulated some slides. I've given them to Philip Okungu. I've shared with him the slides which I've presented here. They're the ones I've shared. They are 9 or 10, just to,
Yes, because throughout the webinar, we did not see any slide, and the attendees were consistently asking me for the slides or letting us know that you are not showing the slides. So I would like to take the opportunity to let the attendees that we will share the slides that Professor Mikeke was using as talking points as he delivered this presentation, if that is all right with everybody. So now I would like to open the floor for the question and answer session. We have both speakers, available. So please send your questions through the chat, or you can ask to be unmuted. At some point, there was an attendee that had raised his or her hand. Is that still the case? Okay, I will ask Dan or Philip Okungu to help me with the questions, because I don't see any question through the chat. So let's see if we can do this in the next 5 minutes.
Yes, we are opening the floor. We are opening the floor for any questions. If there is any questions, any of the experts that would want to ask or any clarifications. And also we are doing the slides so that from the slides you can pick something, then that is okay.
So Maria and Philip, there was a question, I think, for STM from a student who was attending. The name is Emmanuel Young. I don't think he's still around. Maybe he's left. But just for him, maybe he's attending it through, because we've shared this also on the Facebook page. How will STM committees support students and members to undertake research in Africa? That's a question from a student. And I think it's the only question we have on the chat box so far.
Okay, this is Bryant. I know within E56 we have sponsored student members or affiliates to work on ASTM standards in the past. In fact, I had a student from Spain about 2 years ago who was very interested in how to develop standards for nanomedicine, and he wanted to understand that process for part of his dissertation. So yes, ASTM does have the possibility of including students, members on particular work items.
Thank you very much, Dr. Bryant. I will just add the fact that ASTM is open to anybody. We open our membership to everybody. And for students in particular, we encourage them to join us. I put my email on the chat. Students are not active members of 150 technical committees. However, they do have a voice. We do have what is called the Academic Outreach Program and the Emerging Professionals Program. I can give you more details if you would like, and you have my email there. We have a student chapter also in some parts of the world. I believe we have a student chapter in Peru. I hope we have a student chapter, of course, in the United States, and I hope we will one day have a student chapter in Africa. That may be a dream, but you never know, dreams come true. So please, any student in this event today or anybody here today, feel free to share with your students, anybody from the academia, the fact that ASTM is open, is a membership for everybody.
Yeah, Mariah, I was reading through the chat, and there's a question from one which was asking me directly to say whether there is any project in Africa that is connecting nanotechnology and Internet of Things. So I don't know whether they're from Africa or outside Africa, but I want to propose to them to create the first project. What I gave was a solution. From the nanotechnology, you can use, for example, single word nanochips or matte word carbon nanochips. Did I give it? If I was able to show you on the slides there. Quickly, I just show you what I'm talking about. Yeah. So in here, you will see there single word carbon nanotube, which you can fabricate. I fabricated these ones, or the matte word carbon nanotube, and you put in on somewhere a small copper strip and another, create a circuit, and somewhere you create a gap and you put in some carbon nanotubes. Then that can become a sensor, either a sensor measuring resistance, and therefore you can change the resistance of an antenna, or it can be used to sense the existing, gases. So even in the biosensors, when we're talking about biosensors, we're talking of VOC, volatile odor compounds. Volatile odor compounds, just putting around your body. If you begin to, the sensor senses certain, gases around you, smells, it can even relate from some database what maladies or ailments you're suffering from. But also if you expose it to a biodigester, for example, a biogas digester, it can sense whether there is more of methane or there's some ammonia, or carbon monoxide or something like that. These are sensors, and they are small sensors, and they are using carbon nanotubes, which is nanotechnology, to sense. And then you can integrate that one to a battery or to an energy harvesting to give that data to an IoT network, Internet of Things, infrastructure with gateways. So because you have to deploy this in a very dangerous, places, very obnoxious, very smelly places where you can't stand as a human being, you drop in that sensor, which you have formulated, you've produced yourself, fabricated yourself, and then it fits into gateways and the protocols of Internet of Things globally, because the devices for Internet of Things have exceeded 50 billion already, and we're only 7 billion. So we need to ride on the masters or the mistresses. Now, I wanted to respond that way in that way. So you can be the first one to come up with the project. I have the answers, but I want you to come up with the project and the funding.
Thank you very much, Professor Mikeke, for that answer. I think there is another question, and I think that I can address that question. I was actually sending a response, and that is how can how can one become a member of ASTM? I will drop a link in which you can read a little bit more about our membership types. I know for a fact that students can join ASTM free of charge. I do know that there's a fee-based application for organizations, different types of fees for different at different levels. But everybody is welcome to join. I think Dr. Bryant mentioned, you know, the type of memberships we have in the different technical committees, and they're all welcome to join. If it just comes, you know, anybody with an idea can come to an ASTM to develop a standard, and those ideas are welcome. So don't feel shy or afraid to approach us for that. I think there was there's a question from Rwanda. Thanks, Professor Mikeka. Will reach to you in box. You teach one of the courses that are embedded system at African Center of Excellence in LOT in Rwanda. That was not a question, but a statement. So yes, we
Yes, it's
encourage this type.
correct.
Yes, we encourage
It's,
this
it's
type of network.
collaboration. Yeah, networking.
Yeah,
Yes.
yeah. It's a pity, Professor Mikeka, that we did not show your slides, because I was under the impression that you only had talking points. I see that your slides have a lot of information that could have derived
Huge.
a lot of questions. So, you know, we ought to do better next time. But nevertheless, we will share your slides with all the attendees. And by the way, we have 80 people in attendance today, which is a record number, I must say.
Yeah.
If there are no more questions, I would like to turn things over to Mr. Philip Okungu to give us the closing remarks, unless any of the presenters would like to make any final remarks before we turn things over to Mr. Okungu.
No, for me, thank you, Mariah Obrigada, is simply to appreciate the opportunity, and my slides, as I said, only 10 slides. Of course, they're animated, so there's dense information in there. They are liberal. I've already given to Philip Okungu. I'll be very glad to have all the 80 participants have the slides, simply to induce thinking and doing. And we need to move forward as Africa. Thank you. I appreciate that.
And I would like to thank everyone for attending, especially the students. I hope that the ASTM presentation was useful for letting you understand the scope and breadth of ASTM standards and standards in general for global productivity. And I would also like to thank Frank and Maria for inviting me to participate this morning. Thank you.
Thank you so much. So without any further ado, I would like to turn things over to Mr. Okungu for the closing remarks. Thank you very much.
Thank you once more, Maria. I think it was a great opportunity that we had for this session of our last 2022 webinar series. We want to take this opportunity as the African Organization for Standardization through the Office of the Secretary General to express our appreciation to the speakers. I think this is a great challenge for Africa. I just saw in the chat somebody asking the difference between nanotechnology and the Internet of Things. It's a food for thought. You must be aware that already ARSO has started and it's implementing a program on the fourth industrial revolution, and we have a fourth industrial standardization strategy to take us through all of these digitization opportunities that is happening all over the world, and Africa should not be left behind, taking into consideration the FCFTA agreement opportunities in this area and decade. Looking forward, I want to assure our experts that moving forward, we are going to discuss with with the ASTM once more on a webinar series for this 2023. I want to assure you that ASTM has been very consistent. As I said earlier, Maria has been very, very supportive and has been really facilitating this activities based on our mutual cooperation. And we are looking forward to be having more series. We are going to approach the member states once more and the experts on areas of interest where they would want to get more expertise lectures, public consultations like the ones we have been having throughout this time. So once more, I take this opportunity to thank all the experts who have been participating from all over Africa. And I want to reiterate, as we say, that we are going to be presenting certificates of participation for all the STM ARSO webinars that we have had, to give them more value and to make sure that the experts really also appreciated. If there no any other comment, I want to ask Mariam, when I finish, that we will get an opportunity for a photo for our publicity issues and as we also move forward. So I want to take this opportunity once more to thank Professor Chomora Mikeka. I want to take opportunity to thank Brian Nelson and mostly Maria for the facilitation of this great webinar series that we had today. Thank you very much on behalf of the ASO Secretary General. Thank you.
Thank you very much, Mr. Kungu. I really appreciate your closing remarks. I agree with you that this event today warrants a photo, a group photo. Let me see if Mr. Bryant can quickly come back in. I know he had informed me that he has to take his kids to school. It's very early here in the United States. Dr. Bryant, are you still there? That's fine. We will include this photo. We know we can kind of edit and put this photo in there. So my camera is on. I see Dan, I see Philip, I see Professor Mikeka. Let's show our beautiful faces. I don't see my friend Aisha in Nigeria. I see my friend in Tanzania. Okay, I think then we have a full screen now.
Thank you very much. I've taken several. It shall be shared also on the social media pages.
Thank you very much, Dan. Thank you very much, Philip. And thank you, most importantly, to all the participants. Like Philip said, we look forward to future webinars, joint webinars. Thank you. Au revoir. Asante sana.
Au revoir. Bye.
Bye-bye. Thank you. Thank you.
Yeah.
Goodbye.
Bye.
Bye-bye.